Okay. Okay, so last time, if you remember, what we did was we actually left off. I think we completed an example last time, if I remember correct. Actually, you know what? Let me just do it this way. We left off with I think we finished an example last time with, what do you call it? With payout annuities. And, you know, there was a formula there. Basically, what we looked at was annuities, which essentially were, as an example, were retirement accounts. Basically, the idea there was, you know, you're working at a job, remember, and a little bit from each paycheck comes out and goes into the account, and this keeps on happening. So you're making many deposits. That's what happens with annuities. Again, just think about a retirement account. You know, you're saving up for retiring. You know, generally with IRAs, at least, I think I said this last time, you're not allowed to take out money, I think, until you reach a certain age. But anyway, that's a different story. And there was a formula relating all that stuff. You know, I did go through that last time. I think it's in the notes I sent, you know, the outline of the notes, the formulas are in there. It's also in the book anyway, so you don't have to memorize it, which is nice. There is compounding interest going on as well, mostly because the money that's in the account is being compounded. And we are making some assumptions here as well. Namely, and also with payout annuities, the idea there is you retired and now the money is coming out regularly. You are allowed to take it out. You reach that age, okay? Nope, you know, that kind of thing. And you're making regular withdrawals, you know, like maybe once a month, you know, once every 2 months, how do I say this? Maybe once a year even, okay? But you are doing that. And there is some compounding going on. Remember, there's an APR, you know, a percent. So there is some compounding going on. So it's a little bit different than what we saw in chapter 5. Namely, in chapter 5 with compound interest, the idea there was, as you see here on this slide, there was one deposit made. What we would do is leave the money in there, right, and let the account work on its own, so to say. In this chapter, though, what we're doing is we're doing many deposits or withdrawals. So we're making it a little bit more realistic. What we are assuming as well, even though this part, I guess, is not that realistic, although I guess, well, either way, we're making this assumption though, that not just with payout annuities, but really with annuities as well, how often you make a deposit or a withdrawal is the same as it's compounded. Let me say that again, actually. As often as you're making a deposit or a withdrawal from an account, whether you have an annuity or a payout annuity, that's how often it's compounded, unless stated otherwise. So if you're making monthly deposits, then it's compounded monthly. And with payout annuities, if you're making monthly withdrawals, then it's compounded monthly. So that's just an assumption we're making. Now, we're also going to see something different called loans. Before I get to the loans, though, let me just remind you also, I did put the link in although I think it might be the next slide. Oh, no, I didn't. Okay. But the link is also, I put it in the chat. Let me just do it again as well. The link here, what's nice is there's an app called the TVM Solver. I know some graphing calculators do have it as an app. The book actually goes into how to use it if you have a TI-83 or later. But again, you don't have to have one for this class. What's nice is, what makes it even better is at this website, there's actually an app someone made that's a TVM solver. I mean, I was able to download a calculator app. Let me see if I can get the name of it real quickly. It's called G.Calculator. There is a free version, and if you wanted the full version, I downloaded it. It wasn't expensive. It was only $6 if I remember correctly. You don't have to download it if you don't want to, but it basically has all the features of a TI-83 calculator. In particular, there is a TVM app in there. But again, if you don't want to buy it, that's fine. And I've seen also a website that has a TVM solver, not GeoGebra. From my browser said it wasn't secure, so that's why I didn't recommend it. But the GeoGebra, that's the, what do you call it, the TVM app someone wrote. Okay, all right. But what's nice about those apps is you don't have to worry about, having it in your calculator. So that's what's really nice. Okay. Okay, so let me keep going now. Okay. Okay. Here we go. Okay. The next thing we're going to look at are loans. Okay. Basically here, we have seen loans before a little bit in chapter, I think where we first saw compound interest, which I think was chapter 3, if I remember correctly. 4, actually. But anyway, the first time we saw it, compound interest, we briefly looked at loans. Okay. You borrow money and you start paying it back and all that stuff. There, however, we always assume you were paying back one full amount. So here we're going to be a little bit more realistic in that we're going to make monthly deposits to help pay back the loan. So here it's going to be, a little bit more realistic, basically. Okay. And also the kind of loans we're going to deal with here is when the interest is not calculated up front. If I remember correctly, I think this was the case. I honestly don't remember, but previously where we saw loans, when we did compound interest, the interest was all calculated up front. Yeah. So here that's not going to be the case. Okay. What's going to happen is you'll see, depending on when you make a monthly payment, the balance is going to change, and that's why interest is going to change. Remember, interest, when you're lending out money, the interest is how you make money, actually. You charge interest. Okay? Now, there is a general formula. Actually, you'll see it's really just a payout annuity formula. We'll see that shortly. But I do want to illustrate the calculation and the idea first. Also, again, these kinds of loans, we're not calculating the interest up front. That does happen when you do things like an auto loan, a monthly payment. I'm not sure if that's what they do with school loans. I mean, the interest rate is going to be given, but the total amount of interest is not calculated immediately. But for instance, let's say, just to illustrate what's happening, let's say we're going to borrow $1,000, from the bank or whatever. We're assuming also that the APR is, let me get that laser. It's 12%. Okay, but that's the annual interest rate. Okay. We're going to assume as well, since we're making payments, monthly payments, okay, we're going to assume the account is compounded monthly. Again, this is just an assumption here that we've made before, that the account is compounded as often as we make payments. That's just what we assume. Okay. So let's say we're going to make monthly payments of $100. We agree, okay, with our, with our, the bank or whoever we get the money from. Note also that the 12% here, this is the annual interest rate. So what we do is we divide by 12 to get the 1%. That's our monthly interest rate. Okay? So we're basically divided by 12 to get the monthly interest rate to go through these calculations. And now we're going to start making our payments. Now, this is a little bit different than what's in the book, unless I'm missing something. That excuse me, tripping on my words. But basically here, in the book, they start month 1 as the ending balance of $1,000. I'm starting at month 0 because we don't start making payments till the end of month 1. So this is what I'm doing here. Basically $1,000, that's how much we owe, okay? And so during the first month, right, interest is charged. Again, it's 12%, right? But monthly it's 1%. 12% was the annual interest rate. So they're charging on the balance 10% or 1%, that's $10, okay? That's added on to how much we owe. We also make a monthly payment. And in the end, the balance becomes $910. Okay. So again, we make our monthly payment. Again, this is all at the end of the month. We're making our payments, and the interest is calculated then as well. Okay. So in the end, we end up with $910 that we still owe. And then during month 2, the same idea, the $910, right? Okay, 1% of that is $9.10. That gets added on at the end. We also make our monthly payment at the end, and that brings it down to this. You know, and this keeps on going. We do this during month 3, month 4, and so on. Okay, we keep on adding the same monthly payment. Okay, okay. And again, in the book, they start at month 1 where I have 0. Unless I'm missing something, what I'm doing is right, and the book has a typo. Anyway, this keeps on going. Notice that the total interest gets less. Okay, and that should happen because our balance, our ending balance, is going down. Okay, our balance is decreasing. You know, we're making monthly payments. Okay? And there's just something else that comes up. I think it's actually on the next slide. And yeah, it is. Basically, since the interest is higher in the beginning, a larger portion of this monthly payment goes towards the interest initially, and later on, as the interest it's going down, okay, less of the monthly payment goes towards the interest. Again, because the interest is decreasing, and more is actually going towards the $1,000 that we owe. Okay? It's just something I wanted to point out. The book mentions it. To be honest, I don't think it's going to come up again, that point, but I felt better mentioning it. And the formula then, this would be a lot if we were to do this calculation repeatedly, for each month. Although with something like Excel or Google Sheets, it may not be as bad. But to keep on going like every month and do this calculation, it would be cumbersome. But what's nice is we have this wonderful formula. And before I go into that, let me just pause the recording. Actually, speaking of which, okay. Let me just ask this first. Okay. I really like to see that this is making sense.